Very good evening and welcome back to my channel. My name is Himanshu Gupta and today we'll be diving into the unit 2 of the object oriented programming subject, which is the part of the syllabus at Uttarakhand Technical University. So I believe this video will be very helpful for the students. In this unit we will cover function overloading and constructors. Basically we'll cover compile time polymorphism. I have already covered this in one of my video. Polymorphism means one name and multiple form, and in C++ there are two types of polymorphism: compile time polymorphism and run time polymorphism. So compile time polymorphism, in compile time polymorphism we have function overloading and operator overloading. So if you carefully read the syllabus of the second unit, we have to cover function overloading, then operator overloading. We have to overload various types of operator. So I'll be in this video I'll be overloading plus operator. Then we have to overload new and delete operators, overloading special operators. Will try to overload prefix and postfix increment operator and also comma operator. So these are some special operators that will cover in this video. Runtime polymorphism I'll cover in the next video. Basically, I have already made a separate video on runtime polymorphism. In runtime polymorphism, we implement function overriding, and this is achieved using virtual functions and inheritance. I have already created a video on runtime polymorphism. I will provide the link in the description box. So this part is basically compile time polymorphism. We have also to discuss what is the ambiguity. When we overload the function, at the time of calling the overloaded function, there can be some ambiguity. We'll see how to resolve it and in which situation such ambiguity can occur, and we'll also see how we can pass the default function arguments, right? Along with this, we also have to cover function pointers, how we store the address of an overloaded function, and the other topics that we will cover in this video is constructor. We'll cover different types of constructor like default constructor, parameterized constructor, and copy constructor. We also need to differentiate between the shallow copy and deep copy. So these are the topics that I'll cover in this video. So please stay connected and watch the video from beginning to last. So let's start with the first topic, that is first function overloading. Function overloading. So when we declare multiple functions having same name but different parameters in a program, the concept is known as function overloading. For example, let's declare a class, say test, and in the public section let's create three functions: void show, suppose in void show let's write some message inside function show of class test. Now void show print the value of a here, and let's create another function show and pass two arguments this time, int a, int b. So see out a is equal to a and b is equal to b, and this is our class. So this is basically the function overloading. We have declared three functions. We have defined three functions of same name, show, but each definition, the signature of each definition is little bit different. Like in the first definition of show, we have not passed any argument. In the second definition, we have passed one integer type variable, and in the third definition, we have passed two integer type variables. So if I write main function int main, let's create the object of this class test and call all the methods ob.show, ob.show, and ob.show. So what will be the output of this program? The first call will invoke the first version because its signature is matching with the first version, and the second call will invoke the second version of show because its signature is matching with the second call, and the third version will invoke the third third function. So the output of this program will be inside function show of class test. Then the second call will print a is equal to 20, and third call will print a is equal to 5 and b is equal to 10. So this is how we do the function overloading in C++. Now let's discuss. This is function overloading. Let's discuss how we pass the default arguments in the function. How we pass the default arguments in the function. So default arguments. Let's again create a class say A, and in the public section again create a method void show int A comma int B is equal to 35. Cout A is equal to A and B is equal to B. So suppose this is our simple class, and inside main method let me create the object of this class A as OB and OB dot show suppose 30 and 40, and now let's call show method with one argument 50. So what will be the output of this program? In the first call, see, in our show method we are passing we need two arguments of integer type, and we in the first call we are passing two arguments, so the output will be A is equal to 30, B is equal to 40. But in the second call we are passing only the one argument, right? But since in the function definition we have given some default value of B, the function will take the default value of variable B. So the output will be A is equal to 50 and B is equal to 35. So this is the benefit of using default arguments. If we do not supply the value of default arguments in the function call, then function by default takes the default arguments, right? So now let's talk about the ambiguity in the function call. Now let's discuss about ambiguity in the function call. What do we mean by ambiguity in function call? Basically, if the compiler gets confused by the name, that suppose we have two names ABC, ABC. If there are two versions ABC and ABC, then compiler will and you are calling ABC, right? So compiler will get confused which version to call, this one or this one. So this such type of situation is known as ambiguity, right? And now we'll see practically how in what type of scenarios compiler may get ambiguous calls. So let's see it practically using an example. Okay, let's create a class, say test. And define two methods, void show and A double B cout, 20 values of A and B. A is equal to A and B is equal to B. Same way, overload this method and this time define double A int b, and again print the values of a and b. A is equal to a and b is equal to b. Okay, now let's create the object of this class test. Int main test t. Now call the show method with integer variables 2 and 3. Now this is the ambiguous call, right? Because we have a combinations of integer and double and integer. So the compiler will try to implicitly typecast it to the closest type, but the first version of show method expects integer followed by a double, and the second version expects a double followed by a integer value. So when we are passing this 2 and 3, 2 can be treated as an integer or a double, and same way 3 can be treated as an integer or a double. Therefore the compiler gets confused between the both show versions, because both seems like a valid match. Both seems like a valid match. So the compiler is not able to determine which function to use, leading to an ambiguity error. So this is the case of ambiguity. Okay, let's take the another example where ambiguity can arise. Let me create a class test, and in the test class declare two methods: void show pass a floating point type variable x, cout x is equal to x, and one more method, show pass double here, cout x is equal to x. This is our class. Now define the main method here, main create the object of the class test ob, and try to call the show method with some character, right? Return 0. So basically the compiler, when the exact match is not found, it will try to convert this call. uh, it will find the nearest match. Basically it will find the nearest match, but as both float and double are kind of same thing, so compiler will get confused which version to call. So here this is a ambiguous call, right? If we remove one call, it will print 65, which is the ASCII value of a. So I hope using these examples you are now comfortable in function overloading, and now has understood what is ambiguous call and how do we handle it? So the next topic of this unit is, let me show you the syllabus once again. Okay, so we have covered function overloading, default function arguments, and function overloading and ambiguity. Right now, let's cover this one, finding the address of an overloaded function, and after that, we'll cover the constructors, various types of constructors. So, address of overloaded function. Address of overloaded function. Okay, basically to understand this concept, we need to understand the function pointers. Function pointers. In a separate video of pointers, I have explained the pointers in details, like the normal pointers, generic pointer, void pointers, and function pointers. If you have not watched this that video, please go and watch the video, because it is kind of prerequisite to understand this particular topic. I will provide the link in the description box. So function pointers are basically used to store the address of function. Like we use normal pointers. If I want to store the address of a integer pointer, I need a integer. If I want to store the address of a integer variable, I need an integer pointer, and then we can store the address of integer like this. So likewise, we can create a function pointers. For example, if I declare two functions like this, int or take void show, suppose cout inside function show, and that's it. Void show cout is equal to a. So we have two functions, two show functions like this, and I want to store their address in a function pointer. Let me declare the main function. So how will we create the function pointer? The signature of the function pointer should match the definition of the function. So the return type of this function is void. So I need to write void. Then this is the pointer. I can use any name. Suppose I am using name function1 for, in short, I am writing fun1, and it does not have any argument. So I am using blank brackets, and this is our function pointer, right? I can store the address of function show like this. If I want to declare another function pointer, see, in the second show method we are passing a integer type variable. So here I need to pass the integer, and this way I can store the address of the second overloaded function. Now if I want to call these functions, I have there are two ways to call the overloaded functions or these functions using the function pointer. The first way is implicit dereferencing, like this. Function 1, I can call the functions directly like this. This is possible because of implicit dereferencing, right? We can also do the explicit dereferencing like this. One, this is the call of first show function, and 1, 2, this is the call to second function, right? Let me just demonstrate this using the compiler. So this is our compiler. Let me define two functions. And this is the output. Just a second. This is the output inside function show, and a is equal to 10, and inside function show a is equal to 30. So this is how we can store the address of overloaded function and can use the function pointer to invoke the functions, right? So here in this case, let me open the notepad. Here in this particular example, we have used address of functions which are outside some class, right? Now let's see what difference is created when we try to store the address of a class function, class member. So let's declare a class A, and in the public section declare two functions, same functions, show, print some message inside show method of class A, and void show cout. Here pass some integer value here. Okay. Cout A is equal to A. So this is the class. Now I want to store the address of the class functions. Int main. Okay, now let me first create the object of the class, because object of class is mandatory to access the class members. Now how will we define the function pointers? We'll define the function pointers like this: void, and we need to use a scope resolution operator here to define a function pointer to store the address of class members. And likewise we will store the address of a scope resolution operator show. Similarly, void a scope resolution operator fun2, here we will pass int and is equal to same call show, and now we can we can call the members like this using the explicit dereferencing. This will call our first version of show method, and this will call our second version, right? So this is how we can store the function address and can invoke the functions, overloaded functions, using the address of the using the function pointers. Now the next topic is constructors, copy constructors, shallow versus deep copy in C++. As we have already discussed that a C++ class is defined using the keyword class with some name, suppose test, and it can contains various elements like variables, math functions, constructors, and class itself. Class within class is known as nested class. We call it nested class. So we have also discussed that a C++ class or member of the C++ class can have three types of access specifier or modifier: private, protected, and public. By default, all members of the class are private. The private members, we can only access the private members within the class. We can access the private members only inside the class. Means they can only be accessed using the member function of the class, and we cannot access them directly using the object of the class outside the class, right? Now the second one is protected members. Protected members has little bit higher scope than the private members. They are accessible in its own class as well as in the subclass. Subclass means child class. When we will cover the inheritance, we will get to know what is the meaning of base class, subclass, or parent class, child class, and public members are accessible everywhere in the program. We can use them we can use them directly using the object of the class. Accessible everywhere in the class. Now let's talk about the different members of the class. So some students might be confused that which members we should make private and which part of the class we should keep as public. So the rule of thumb is that the member variables of the class, the variables of the class are generally declared as private, and the functions or methods are declared as public. In 90% of cases, 90 to 95% of cases, this rule holds. Now in this particular video, we'll be talking about different types of constructors. So basically, first we'll discuss what is constructor. Constructor is a special method, is a special function that is used to initialize the member variables of the class. The name of constructor must be same as name of class, and it does not return any value. Constructor is invoked automatically when the object of the class is created So this is the basic definition of constructor. We have various types of constructors like default constructor, parameterized constructor, copy constructor, etc. So today we'll be talking about these three types of constructor: default, parameterized, and copy constructor. So basically, default constructor is the constructor in which does not take any parameter. Let's write a simple code. Class test int a. This is the private member by default. This member is private. Let's declare the public section of the class and take a constructor test. This is known as default constructor. as we are not passing any parameter into it. Let's initialize the value of a with some default value 0. Test x. This is known as parameterized constructor. And let's declare another constructor test of, in which we'll be passing the reference of the test class, and this is known as copy constructor. So we can copy the value of this object into this current object using ob.a, right? So let's take one function void show, which should print the value of a, and this is our class test. Now let's declare the main method. Int main. Declare the object of test class. Let's create 3 object of the test class: test t1, test t2, and test t3, and pass the object t2 here. So basically, when the first object is created, it calls or invokes the default constructor, which is the first constructor in our case. This invokes the parameterized constructor, and this invokes our copy constructor, right? Now let's call the show method one by one using all the objects. t2.show and t3.show. Return 0. So I think you can predict the output. The output of this code will be t1.show will print a is equal to 0, t2.show will print a is equal to a is equal to 2, and t3.show will also print a is equal to 2 because t3 is the copy of t2. Now let's run this in our. Okay, in order to save the time, I have already written the code here. So as we just discussed, I have created a class test and take a private member variable a, and I have declared 3 constructors. This is our default constructor, parameterized constructor, and the copy constructor. This method show is printing the value of a. I have created 3 objects. This is invoking our default constructor, parameterized constructor, and this will invoke our copy constructor, and we are simply printing the values of A in all the cases. So as expected, the first case is printing the default value of A, that is 0. In the second case, also we are getting A is equal to 5, and in the third case also we are getting A is equal to 5. Now the interesting thing here in this example is that the C++ uh, by default supplies its own copy constructor. That means if I even do not write this code, if I remove this code, then also this code will run and we will get the same output. You can check. I have removed my copy constructor code. Still, I am getting the same code because by default C++ supplies its own copy constructor and we can use it in both the ways. This is the one way of invoking the copy constructor. The another way of invoking the copy constructor is we can create the object T4 and assign it the another variable, another object, say T2. So this will also invoke the copy constructor, and T4 dot show should print the value of A is equal to 5. So if I run it again, you can see now our 4 objects are printing the 4 values of A, and since the last 2 objects are the copy of object T2, in the last 3 lines we are getting the same output. Now I think you have understood what is copy constructor. Now the question arises, if C++ supplies its own copy constructor, then why do we need to define our own copy constructor? In which situation we should define our own copy constructor if C++ supplies its own copy constructor? So let us discuss that case. See, if we are using the normal variables, there should not be any problem with the copy constructor. But when we deal with the pointers, the copy constructor will create, the default copy constructor will create the shallow copy of the object, and it will not create the deep copy. So let me give you an example what I mean to say by shallow copy or deep copy. Okay, in our previous example, if we carefully check the code, if we carefully see the code of copy constructor, then what is being happened? See, this is the definition of class test, and it contains a variable A. Right. First we have created a let's right here. This is our suppose T1. Here default definition of the constructor will invoke, and our A becomes 0. In the second case also, for T2, we have passed some values 5, and our A of T2 will be initialized with 5. Then in the third case, we have created T3. We have physically created T3 and passed T2. So this OB is basically alias of the object T3, and in the we are assigning A of T3 the value of this alias dot A, which is equal to 5. right? And see, so here in this example, all the three objects will have separate memory location, and all the A are given separate space in the memory. But let's consider one case. If let me take the same example. I will come to this soon. Let's rewrite the code, class test, and now this class contains two variables, suppose int a and a pointer p, right? We all know that pointer is used to hold the address of that type. Let's declare public section and a constructor test. This is our default constructor. Assign the default value of a, and since this is our pointer, we need to assign some space here using the new keyword new int and 0. So this will initialize an integer type of space for this pointer. Basically what this line will do, this will allocate some space, this will create a space of integer type, will initialize this space using 0 and return the address, and the address of this space will be assigned to p. Now let's take another constructor, test int x and int y. Now again a is equal to x, create a space for pointer p, means we are creating a memory location, will initialize it with y, and the address of that memory location will be stored in p. New int y. Okay, fine. Now let's create a copy constructor, test and pass the reference of this object. Now a is equal to ob dot a, and what we are doing, p is equal to ob dot p. So what will, here we are just copying the pointer. We'll see what will happen here. Then void copy, void show, print the values of a and p, cout a is equal to say a, and let's print the value of this pointer, p contains value at p. Let's print the value at P, and that's it. This is the definition of our class test. Now again, let's in the main method create the object test T. This will invoke the default constructor, then test 5 and 10. This will invoke this. Now I'll show you this T1, T2. Now let's create T3 and pass T2 in it. This will create the shallow copy. This will create the shallow copy. This is what I am talking about, and that's it. T1 dot show, T2 dot show, T3 dot show. Now let's discuss what is the problem with this code. Here in this code, we have created 3 objects, right? So let's create 3 boxes. This is our T1, T2 and T3. Here we have 2 variables A and a pointer P, A and a pointer P, A and a pointer P. So what is happening? When we create this object T1, the default constructor will invoke, A will be initialized with 0, and there will this constructor will create some integer type memory and will initialize it with 0 and return the pointer. Suppose the address of this location is 1000, this address will be stored here. The value of P will be 1000 if the address of this location is 1000. Likewise, when we have created this object T2, in the same way, A will be initialized with 5, and there, this line will create an integer type memory, which will be initialized with the value supplied in the constructor 10, and if the address of this location is 2000, this address will be stored here 2000. The value at 2000 is 10, but this our pointer will be storing this location 2000, right? Now what we have done, we have in the third case, we supplied this T2 object in this in the copy constructor, and what copy constructor is doing, it is copying A with A will be initialized with 5, and P will now contain the same address 2000. So here what is actually happening, the A of T3 and A of T2, this is T2, the variable A of T2 and variable A of T3 have separate locations, but the pointer P are pointing to the same memory location. I mean to say that there is a location which contains the value 10, and suppose its address is 2000, then both of these pointers T2, P of T2 and P of T3 are pointing towards this memory location. So it does not have its own memory to contain the pointer P. So what will happen if we call the destructor? If we call the destructor, Like constructor, C++ also has destructor, and destructor is declared like this using a tilde sign and the name of class. This is the destructor. By default, uh, C++ supplies its own destructor, but if you have uh, allocated the memory using dynamic memory allocation, then it is mandated to deallocate the memory using free or delete function, right? We use two type of functions for dynamic memory allocation. We use malloc, which is a C++ function. We can also use calloc, which is again a C function. Both of these functions are C functions and returns a void pointer. They returns a void pointer, and the memory allocated using these operators, using these functions, can be deallocated using free. While if we are allocating memory using new keyword, then it should be freed using the delete keyword, right? Though C++ supplies its own destructor, but if you have used dynamic memory allocation method like new, then we should delete it using the delete keyword. When we need not to explicitly call the destructor of the destructor of the class is automatically called when the object goes out of scope. So when the object goes out of scope, the destructor is called automatically, right? So basically what will happen here in this case, if inside the destructor, if inside this destructor I try to delete p, then what will happen? Basically, first we have created three objects, T1, T2 and T3. If this goes out of scope, this will be called, there will be no problem. If this goes out of scope, see, T2 and T3 both have P, which are pointing towards the same memory location, This will try to deallocate the memory. For the first time, the operation will be successful. And when this T3 will go out of scope, this will again try to deallocate the memory which has already been deallocated by the destructor. So there will be a warning message, there will be an error message, and let's see this code that we have just discussed in our uh, online compiler. I have already written the code. So like I just discussed, this is our uh, class. I have taken two variables. One is integer type and the second one is integer type pointer. I have in the same way I have taken three constructor. This is our first constructor, default constructor, second constructor, and this is our copy constructor. So this is our copy constructor of ours is doing the shallow copy. Shallow copy is creating the shallow copy because we are simply copy pasting the uh, address from one location to another location, and we are not physically allocating the you know extra space or separate space to store the variable. This is our constructor. This is our destructor, sorry, this, and if I run this, suppose first let's not delete this pointer p, and let's try to run this. So you will see that a, these are our four objects. A contains, a is equal to 0, p contains 0, a is equal to 5, p contains 10, 10, 10. We have created three copies using copy constructor, and we have created four objects, and four objects are deleted successfully, right? So there is no issue till now. But if I try to delete this pointer p, then what will happen? Double free detected in cache 2, t cache 2, object destroyed. And then after when the second object tries to free the already deleted space, already freed space, it is giving us a message, and the program finished with exit code 134, right? So this is the problem with the, this is the problem with the shallow copy, with the shallow copy of the object, and the and its solution is the deep copy. Its solution is the deep copy. So let's see how we can implement the deep copy. Basically what we have done in our last shallow copy constructor, the shallow copy constructor was implemented like this: a is equal to ob dot a, and we have not created any new memory for our pointer p, and have simply copied the value of the address contained by the p of this object into our pointer, right? So what is the solution? This is shallow copy. How should we handle it? We should handle it like this: test, test, this line will be same. Okay, now allocate some memory to p, allocate a new memory location for this p using new int. Since this is our integer type pointer, we have created a separate memory location with suppose address 1000, and now this p contains this address. And now what we can do, we can say, we can write value at p, value at p means the address contained by the p. This is the the p will be equal to value at ob dot p, right? So whatever address key variable p pointer of this object contains, it will be copied here. So suppose this is ob and its p contains address 2000, then here p will be 2000. So you can see that now we have made a separate memory space for our this pointer, and therefore there should not be double delete error in this case, and this constructor is known as deep copy constructor, right? So whenever with the normal variables, you know, our copy constructor will work fine. But when we are dealing with the pointer, when we are having pointers in our code, we should supply our own copy constructor, which can make a deep copy of the variables. So I think this tutorial has cleared your doubts regarding shallow copy and deep copy. Let's make a deep copy here. P is equal to new int and value at P is equal to value at object dot P, and this is now working absolutely fine. You can see there is no double delete error and all the objects are destroyed successfully using the destructor. So, okay, so far in this video we have already covered function overloading, default function arguments, function overloading and ambiguity, finding the address of an overloaded function. We have already covered constructors, different types of constructors like default constructor, parameterized constructor, copy constructors, and have also seen what is the difference between the shallow copy and the deep copy. So now our last topic is operator overloading. So in operator overloading, we will overload plus operator, will also overload plus operator using friend function. Then we will overload new and delete operators. After that, we'll overload comma operator, and we will also cover postfix and prefix, postfix and prefix increment operators. So let's begin with the first operator. Overloading addition operator. So in this example, we'll overload the plus operator to add two complex numbers. Right? So what we will do, we'll define a class complex. Basically, the plus operator is used to add two variables, right? But a class, a complex number contains two numbers, the real part and the imaginary part. So we will redefine the plus operator to add two complex numbers. I mean, real part should be added with the real part and the imaginary part should be added with the imaginary part. So let's define a class complex. I'm taking two private members here, real and imaginary. Now let's use constructors to initialize the variables of complex class. I will use a default constructor to initialize it with the values 0 and a parameterized constructor and r1 and I1, suppose r is equal to r1 and I is equal to I1. So the constructors will initialize our member variables. Now we will define a show method to print our complex number. Cout first print the real part, then sorry, real part, then plus I and imaginary part. Okay, now our main logic. So operator overloading is done using a special function called operator. So we define the operator function like this: return type, then we use keyword operator, and then we write the operator that we are going to overload, and after that list of arguments. So this is the member operator function that we'll need to implement here in order to overload the plus operator. So this our operator plus function will return the object of complex class. So I am using complex operator plus, and inside this we can pass a constant reference of complex class, constant reference of complex class, and inside this function we can simply return complex. Real part will be added with the ob.real, and imaginary part will be added with the ob.imaginary, and that's it. This is our complex class. Now let me define our main method. Inside main method, let's create two object of complex class. Say complex C1, pass some values in this. Complex C2, suppose 4 and 2, and now add them like this. Complex C is equal to, or C3 is equal to C1 plus C2. Now this will invoke our overloaded plus operator. This will invoke our overloaded plus operator, and let's print the values of all the objects using show function. C1 dot show, C2 dot show, and C3 dot show. So what will be the output of this program? The output will be C1 dot show will print 2 plus Ti, 2 plus I3, and C2 will print, C2 dot show will print 4 plus I2, and finally when we are calling the overloaded plus operator, it will add C1 with C2, and our C3 will become 6 plus I5. So this should be the output of our code. Now you must be wondering that this operator is the member function of this class, and we know that member function of class is invoked using the object of the class. Then how this C1 plus C2 is invoking operator function. So implicitly this will be converted into this type of call, C1 dot operator plus, and this C2 will be passed as argument in the call, right? So let me show this using our online compiler. Okay, so using namespace std, define a class complex, class complex int real part and imaginary part, then define two constructors, one default constructor and one parameterized constructor, and int r1 int i1, initialize r with r1 and I with I1. Now define our show method, void show in the real part first, then plus I and imaginary part. Now our definition of our overloaded plus operator, pass the complex address of OB. So now return an anonymous object. The real part will be added with the OB dot real and imaginary part will be added with the OB dot I. Now this is the definition. This is our class. Now declare the main method. So declare two complex functions, two complex object of two complex class C1, 2, 3, one more object C2, 3, 4, and complex C3 is equal to C1 plus C2. Okay. Now let's print the values of all the objects using show method. Show C2 dot show and C3 dot show. Okay. Now let's run it. So this is the output. So first object is 2 plus I3, second object is 3 plus I4. So real part is added with the real part of another object, and imaginary part is added with the imaginary part of another object. I have already explained how this call is internally converted. I mean, when we are calling the overloaded plus operator like this, C1 plus C2, this is equivalent to C1 dot operator plus C2, right? So what we are doing in the definition, the real part is added with, so this C2 is being passed as parameter, and C1 is following the method. So this R belongs to C1 and this OB dot R belongs to C2. So like this, we are adding uh, the two complex numbers. Now let's see the case when we want to implement this using the friend function. Now what problem we will face? Actually, since friend function is not the member function, if we want to implement this operator function using the as a friend function, then what problem we will face? The problem is since the friend function is not the member function of the class, we cannot call it using the object of the class. I mean, this call will not be valid. So in that situation, we need to pass both the objects in the friend function. So our call will be like this. I mean, I need to define the friend function like this. Friend complex operator, sorry, plus and constant complex, suppose object 1 या OB1 and constant reference, this is the reference complex OB2, right? So this should be the implementation of friend complex function, friend operator function. Let me demonstrate this using our online compiler. So I need to only change this part. I will write here friend complex operator plus OB1 and constant complex. This is our friend function. Now this can be deleted. So now I can define this function outside the class. Here we can remove this. Okay, now complex, again we'll use the same statement, return complex, but inside this ob1 dot real plus ob2 dot real and ob1 dot imaginary plus ob2 dot imaginary. Okay, so this should be the definition. Now let's try to run this. Rest all the code will remain same. Okay, and you can see our code is running fine. So this is how we can implement the definition of overloaded operator using the friend function. Let me paste this code. In our notebook, let me increase the font size. Okay, so now let's discuss the another operator. Let's overload the another operator. After the plus operator, let's overload new and delete. So basically new is used to allocate the memory dynamically, and we use new function like this int p is equal to new int, or like this. The memory allocated by the new function is deleted using delete function, delete p, like this, right? So I have already covered dynamic memory allocation in my previous videos. So if you have any doubt regarding how we use new and delete, and how we use malloc and calloc and free function, I have covered them in a separate video, right? So what we need to do, let's create a class, say test, and declare a variable here. Let's keep everything public. Declare a variable here, data, and now overload the new function. So the return type of new function will be a void, a pointer of type void, operator new. See, new function is used to allocate some memory. So we need to pass the size of the memory block inside the new block. So uh, basically we will pass the size. If you recall how malloc function is used, inside malloc function we use size of, and here we pass the data type. So likewise, the functionality of new will be implemented in the overloaded function using the malloc, right? So we need to pass the size, and this size t operator, this size t variable is the basically unsigned integer. So I'm defining here size, and now let's create the memory here using malloc and pass this size. Now we need to simply return this, return p. So this is the uh, simple definition of our operator new. Likewise, we use the delete function to delete the pointer, to delete the memory uh, being referenced by the pointer. So again void operator delete. So what is the requirement of the delete function? A void type of pointer, a pointer basically. So here we have written the void pointer. So let me pass a void pointer here in the delete function, and we can simply pass a message here like custom delete operator called. and then you can free the memory occupied by this pointer. Actually we should print a message here also, so that when the new operator is called, we can be notified. So let me write the message here: custom new operator called, and we can also print allocating you know this much memory. That's it. So inside the main method, in main, let's create the object of the test using the new operator test. Suppose t is equal to new test. Let me initialize the data member of this class as 30. So we can print this is equal to, sorry, data is equal to t data, and then after this we can delete t. So this will call the custom t method, and the appropriate message that we have given in the function definition will be printed. So this is our operator overloading using new and uh, delete function. Let me just demonstrate this using our online compiler. Let's remove this code. Class, say test, declare a variable, everything is public, data, now let's redefine operator new. Inside new I need to pass the size. Let me print a message: custom new operator called and allocating bytes. So void is equal to malloc, pass the size here, and return p. So this is the definition of our overloaded new operator. Now let's overload the delete function, delete operator. Operator delete. Inside delete we need to pass a pointer. Here also print a custom message: like custom delete function called not function operator called, and we can say deallocating memory, and let's use the function to delete the memory. That's it. So this is the custom definition of our new and delete operators. Now let's create the object of test class. Test t is equal to new test. So this will call the custom new operator, and we can initialize its data member is equal to 50. Then we can print it, see out data is equal to data expression, and after this we can simply call the delete function to delete the memory. This will invoke our overloaded delete function and return 0. So let's run it. Okay, I think we have not added the semicolon here after the class. Okay. So custom new operator called allocating 4 bytes. Data is equal to 50. Custom delete operator called deallocating memory. Okay. So this is how we can give overload new and delete function. So let's come back to our notepad. So we have already overloaded plus operator, new and delete. Now what is left this comma operator and postfix and prefix operator. So let's first overload comma operator. Actually, let me first discuss what is comma operator with you, and then we will overload it. So comma operator is basically used like this. If suppose I write int a is equal to 10, 20, then comma operator is evaluated. I mean the expression is evaluated from left to right. The left expression is evaluated first, and its result is discarded. I mean this 10 will be discarded, and the right expression is then evaluated, and then its value is returned. So basically we don't have expressions here in the with the comma operators. We just have values. So ultimately if I print the value of a, this will print 20, right? Likewise, if I take another example, suppose let me define x is equal to 10, and if int y is equal to x is equal to 20 and x plus 5. So this expression will be evaluated from left to right. First left expression is evaluated, its value is assigned, and then its result is discarded, and then right expression is evaluated and will then be assigned to the y. So what should be the result here? First x will become 20, then at the right side uh, this expression will return 20 plus 5. So if I print y, this will print 25, right? So now what is our objective? How we are going to overload this comma operator? If I am writing something like this x comma y, our I will overload the comma operator to add this x and y, right? So our this will be overloading this comma operator to perform x plus y. That's it. This is our objective. So let's create the program. Let's write the program. Simply we need to create a class test. Inside the test class, let's take a variable a, and in the public method use a constructor to initialize this int a. So this a is equal to a, and after that let's overload the comma operator. So the comma operator will return the object, and this is our signature operator comma, and we will pass the constant reference of test class. Now we will return test and a plus ob dot a. That's it. This is our class, and what we have to do, this is our main method. Return 0. So let's create the object of this class test t, say 20, and create one more object test t1, say 40, and now test t2 is equal to t comma t1. Now let's print the value of t2 dot a. I need to define one method which should print the value of v. So let's declare void show here, and inside this simply print a is equal to a. So we can print the values of a using all the objects t dot show, then t1 dot show, and t2 dot show. So the output should be 20, 40, and 60. So this is how we can overload our comma operator, and let me just demonstrate it using the online compiler. Okay, so let's delete this code. Int a, use a constructor to initialize the data variable, member variable of the class is equal to a. Now a show method to display the value of a. Cout is equal to a. Now let's overload the operator, comma, pass the constant reference OB and return test, sorry, return test a plus OB dot. That's it. Inside main method, we need to create the object of test class test t, say t1, 20, create one more object test t2, 40, and test t3 is equal to t1 plus, sorry, t1 t2 comma t2, and let's call the show function show t2 dot show t3 dot show. Now let's try to run this. I think there is some problem. Let me check. Redeclaration of test t2. Oh, actually this is t3 not t2. T2 we have already declared, and t1 plus t2. Oh, sorry, t1 t2 t3 t1 t2 t3. So okay, now we are getting the desired output. A is equal to 20, A is equal to 40, and A is equal to 60. So this is how we can overload our comma operator. So let's come back to our notepad and let's overload the last operator, our unary increment operator, right? So as we already know, this unary operator is of two types: prefix increment operator and postfix increment operator. So suppose a is equal to 5 and I write a plus plus or plus plus a, then both of these statements will increase the value of a by 1. So there will be no difference in these two statements in this particular case. But if we are doing the assignment along with the increment like this, suppose b is equal to plus plus a and b is equal to a plus plus. So in this case, first increment will be done and then assignment. So if the value of a is 5 here, both a and b will become 6, right? But in the second case, if the value of a is equal to 5, then first 5 will be assigned to b, so b will be 5, and then a will become 6. So in this case, the values of a and b will be different. So this is what we have to do. We have to overload our plus plus operator for the object, right? uh, I mean, we can use the increment operator with the unary increment operator with the variables, but this time we will overload it so that we can use it with the object of the class, right? So this is our objective. Now let's try the code. Let me declare the class, say test. Inside this class, let me declare a variable count, and let's use a constructor test, suppose int. Let's use a default constructor simply to initialize it, the count with 0. Okay, now let's overload it. First we will overload the prefix increment operator. So test will return the reference to the test object, then operator, this operator we are going to overload. We don't need to pass anything in the function. Okay, so here we simply need to increment the count, and then will return the current object, return this, right? So here we are, sorry, I forget to plus plus this. We are overloading the plus plus operator, and this is our prefix increment operator. Likewise, implement the postfix increment operator. Okay. See, I have already told you that if suppose a is equal to 5 and b is equal to plus plus a and b is equal to a plus plus, what is the difference between these two statements? In the first statement, first increment is done, then assignment, and in the second statement, first the value of a is returned and then increment is done. So here in this definition of overloading of postfix increment operator, we will first return the current value, current state of the object. We'll store this, the current state, in the object test. Let me call this temporary object temp is equal to this, right? So current state we have stored in this temporary in this object temp, and then we can do the increment count plus plus, but we have to return the value first. So the old value, this temp will be returned, return temp. So this is our postfix operator. Now let's declare a method, say get count, which will simply return the value of count. Return count. Now let's define our main method. In main, so basically let's first declare a variable object of the class test. So since we have defined a default constructor, this is t and this is our count. Count will be initialized with 0. Now if I use plus t, this will invoke the uh, you know overloaded prefix increment operator, and if I print the value of t now using t dot get count, let me enter. So this statement will print 1, right? Now if I invoke t plus plus, and again if I call get count, this will print 2. But if I declare some object like this, test t1 is equal to t plus plus, right? And let me print the values of both t1 dot get count, give some space, and t dot get count. So what will be the output? And what will be the output here? See, t plus plus, since we are using the postfix operator, first the value of t will be assigned to t1. I mean t1 will be equal to 2, and then t becomes 3. So it will be 2 and 3. And if I define some another variable, t2 is equal to plus t, then the last value of t is 3. So here both will become 4. So if I again print t2 dot get count, and t dot get count, both the functions should print 4 and 4. So I think you have understood my point. Return 0. So this is how we can overload these special operators. Let me just demonstrate this using our online compiler. Okay, let me call this count. Simply initialize count is equal to 0, and let me define a method in get count and simply return count. Now sequence of test operator, we are overloading plus plus operator, and we don't need to pass anything here. Simply what we need, so here simply plus plus count and return this. Let me copy paste this to overload the postfix implementation. So count plus plus. Let me create a temporary variable temp test temp is equal to this. So in place of this we'll return temp. Now our function t let me use t plus plus and print cout t dot get count. Again use plus plus t and again print the values of t. Now let's create a object, new object test t1 is equal to say t plus plus and print the values of both cout t1 dot get count, give some space and t dot get count. Make a copy of this. Actually, let me make the copy of both of this line. Now let me define t2 and plus plus t, t2 and t. Okay, so now let's run the program. What is the error? Test cannot be overloaded with test and reference to local variable temp return. Okay, sorry. Actually both these the signature of both the overloaded increment operators become same, so we need to pass a distinguishing factor, like we need to supply the int here, and also we, since this is a temporary variable, we can remove this from here. Let me try running this now. Okay, so now it is running fine. So you can see when we are simply increasing the value of object using prefix or postfix increment operator, there is no difference. They are used to increment the value by 1. So in this line we have used postfix operator along with assignment. So first value is returned and then assignment is done. So that's why the value of t1 is 2 and then our t becomes 3. But in the second case we are using the prefix increment operator. So first t is increase, the value of t becomes first, the value of t becomes 4, and then it is assigned to the t2. So I hope you understood this. Let me just copy this. Compiler. Okay, let me also correct the code here. So basically we need to pass some argument here, and this is not required. Okay. So I hope you have enjoyed the video. This comprehensive video has, in this comprehensive video, I have tried to cover all the topics of your syllabus. I have started with the function overloading, function overloading. Then we discussed default function arguments. After that, we also discussed how we find the address, overloaded functions, and we also discussed the function overloading and ambiguity. Right? So after this, we discussed about constructors. We discussed three types of constructor: default constructor, parameterized constructor, and copy constructor. We have also seen the difference between the shallow copy and deep copy. In our discussion of shallow versus deep copy, we understood that if we are using the normal integer variable or floating point variable, then all the members are allocated separate locations. But when we are dealing with the pointers, a shallow copy is created, and in that case we need to handle you know copy constructor differently. We have seen the example. After this, we performed operator overloading, and we overload various operators. First we overload plus operator, then we overload plus operator using friend function, we have seen uh, since the friend function is not the member function of the class, so we need to handle the friend function differently. After this, we overload new and delete operators. After that, we overload comma operator, and finally, in the last part of the video, we have overloaded the prefix and postfix, increment, operators. So thank you very much for your patience. I hope you have enjoyed the video, and I hope this video will help uh, in securing good marks in your end semester exams. Thank you very much. We'll see you in the next video.